So today, students, we're going to do and show some applications that can be done in real life from quadratics. Now, the other day, have you ever driven down the road and you've seen like skid marks on the road? And you're like, oh, somebody was going fast and couldn't quite make that turn or whatever, right? Or something happened. Well, they, after gathering data for several years and looking at it, they realized that the data for how fast you were going versus um, how long it took you to stop turned out to look something like this if you were graphing it. And they noticed that it was taking on the form of what we call a quadratic. And so what they did is they kind of made a model based off of that. Like, this is the line, and maybe it didn't hit every point perfectly, but they gave it kind of a model. And this is what it would look like if you were going 10 miles an hour. It would take you like 17 feet to stop, or 20 miles an hour, 17 feet, or whatever it was. And they got up here, and but what they noticed is that, oops, the faster you were going, say you were going 70 miles an hour, it was going to take you a lot longer to stop. And it wasn't a linear thing where it created a line, it happened to be quadratic. And so they came up with this formula, and it turned out to be something very ugly looking, like 0.03214 something or other, x squared minus another nasty thing plus 0.015 or something like that. Anyway, it turned out to be a quadratic equation. But what they used that formula for then is, after they generated this model, they were able to then measure your skid mark, right? And then they would measure the length of it. And then they put it into the quadratic, and they could figure out how fast you were going at the time of impact, or basically how fast you were going when you started your slide into your braking. And then that's kind of how they can determine who gets the ticket or what's going on. And it's all done by mathematics. There, the police just have this formula all nicely set up for them, but mathematicians somewhere gathered that data and learned to interpret it and make a model, a mathematics model for it, and they were able to figure this out. So we're going to look at some mathematic models that apply quadratic equations. They're going to be word problems, and we're just going to learn how to solve them. So read the problem carefully at least twice. Decide what is asked for and assign a variable or variable expression to the unknown quantities. Organize a chart, table, or diagram relating all the information provided, and then form an equation. Okay, solve the equation and then check your answer. So here we go. One number is 4 more than another, and the sum of their squares is 296. Okay, so I'm going to read that again. One number, I have two numbers, okay, is 4 more than, that means add 4, another. So there's my second number. And the sum, that means addition, of their squares is 296. So I am going to try this. So I'm going to have these numbers. I'm going to let the first number be, well, I'm going to try it here. One number is 4 more than the other. So I'm going to let the second number be x. The other number is going to be, one number is 4 more than the other. So there's two numbers, isn't it, right there? And the sum, let me erase that here. Just do it like this so you can see it. Number 1, I'm going to call x. Then the other one, number 2, I'm going to call 4 more than x, right? Those are my two numbers. And it says the sum of their squares. The sum of their squares. There's a square plus this one squared is 296. Now, you guys should be already hearing in your head, don't ever, never, never do that. Don't ever just square it evenly. Make sure you factor it out. I mean that you FOIL it out or distribute it out. So that really becomes x squared plus, this is x squared plus 8x plus 16 equals 296. Now, what are the numbers? That's really telling us to solve for x, isn't it? I used x as my variable. We could have used something else. So I need it to be 0 here. So I'm going to minus 296. And I'm going to collect like terms. So 2x squared plus 8x plus 16 minus 296. Well, 296 and 16, isn't that going to give me 280 and negative 280? So I have 2x squared plus 8x plus or minus 280 equals 0. And now I'm going to look for a GCF, and there is one. It's 2, and I want that because I want a to be 1 if possible. So I'm going to factor out a 2. Okay, so here I'm going to build this here. We'll go through all the factoring steps. A negative 140, and they got to add up to 4. And I know like 1 times 1 is going to be positive, right? 1 is going to be negative, and the positive is going to be the negative, the bigger number. Since this is really small, my two numbers are going to be probably fairly close together. And the first thing that comes to mind is a plus 14 and a minus 10. 14 times a negative 10 is a negative 140. 14 plus a negative 10 is 4. Since my a does equal 1 in this new one here, I can say 2 times x plus 14 times x minus 10 equals 0, and then I can solve. So 2 I don't worry about, there's no variable with it, so I just have x equals 14, a negative 14, and x equals 10. Now we have to say, what are the numbers? Well, the numbers are not just a negative 14 plus 10, because a negative 14 and plus 10, they're not 4 apart. If you look on the number line, they're way apart. Negative 14 is over here and 10 is here. So you're actually going to have two solutions. You're going to have a solution of negative numbers, and you're going to have a solution of positive numbers. So let's look at this. If x is 10, let's say it's 10, then what's the next number? 10 plus 4 is 14. So my first set could be 10 and 14. And what could my other set be? What if x is a negative 14? Because that was the other possibility I had. Negative 14 plus 4 is a negative 10. So the other possibility is a negative 14 and 10 would be my other possibility. So in this case, there are two sets of numbers that would satisfy all this up here. And we could just look at it, 10 squared plus a negative 14, or 10 squared plus 14 squared. That would work. And a negative 14 squared, that becomes a positive, plus 10 squared, that works. So we're going to get there. It's just, I can't have, my answer cannot be a negative 14 and 10 because that doesn't fit this part right here. So I had to go back and find the second number. I only found x. I didn't find the x plus 4. And because I would have two possibilities for x, then there's two possibilities for the second number. Then they do the factoring, and then they're saying x could be a negative 14, and if x is a negative 14, then the x plus 4 is a negative 10, or the other possibility, if x is 10, then the other number is 14. So two sets of answers, 10 and 14, or a negative 14 and 10. And then you could check them and see. Okay, in an orange grove, there are 10 more trees in each row than there are rows. So I have these trees growing, right? These are the rows. There are 10 more trees in each row than rows. So if there are rows, it says there are 10 more trees in each row. So trees would be R plus 10. Okay. How many rows are there if there are 96 trees? Well, so here I have this array of trees. We want to know how many rows there are. We don't know that. We don't know how many rows there are. And we don't really know, but we do know how many trees. And how do I find out? I take rows times trees equals the total trees, right? We got to kind of understand that. So rows times trees equals the total trees. So rows, which is represented by R, times the trees, which was r plus 10, right, for row, then that's going to equal 96. So I get r squared plus 10r equals 96. I want it to equal 0 here, so I'll take away r squared plus 10r minus 96 equals 0. So I'm going to erase all my pretty artwork here and my trees, so I have room to do all my work here. Okay, so if I factor that, and I can just do this because a is 1, so I know it's this and this. What makes 96? Let's think about that. What is 8? Well, here's what I want. I want it to be, here's my x. A negative 96 here, but 10 away from each other here. So I got to think about that. And it looks like I'm going to have a positive and a negative, and the larger factor will be the positive. So I could have a negative 1 times 96. That doesn't work. Negative 2 times what? Oh, 48. That's not going to work. I could have a negative 3 times 32. No. Negative 4 times 24. We're getting closer. Notice how that's getting closer to 10. So negative 6. Let's try that. Negative 6 goes into that times 16. And I think I found it right there. If this is a negative 6, this is 16. Because a is 1, so I can go r plus 16 and r minus 6. So it looks like r plus 16 equals 0, or r minus 6 equals 0. So r equals a negative 16, or r equals 6. Now, which one of those makes sense? Can I actually have a negative 16 rows in a garden? No. So I'm going to just throw that one out. But I can have 6 rows, right? If I have 6 rows, how many trees are in each row? Well, I put the 6 here. 6 rows. Well, that's all I needed to know was 6 rows, right? How many rows are there? 6 rows with 16 trees in each row. But I can't have a negative 16 row. So that's, see, when we start to work in the real world, there are some answers that just won't work. They work mathematically, but they won't work in the real world because I can't measure out a negative 16 rows, particularly in gardening or building or anything like that that's truly countable in our world. We can't have negatives. So, except for money. All right, let's go ahead and look at that in temperature. See them do it. They're going to get the same thing. Like, they draw much better trees than I do. It's just really sad. We get r equals 6, and that's our rule. Okay, here is a rectangle, has an area of 135 square meters and a perimeter of 48 meters. What are the dimensions on the rectangle? So let's think about what we know about rectangles. This area is 135. And the formula for area equals length times width. Now the perimeter, right, is 48. And we know that perimeter equals 2 lengths plus 2 widths equals the perimeter. Okay. Now what do we know? We know perimeter equals what? 48. So here's what we know. We know the area, 135, and we know the perimeter. So what if I did this? What if I said, I'm going to just solve for W. I'm going to solve for W. So if I did that, I would divide each side by L, right? So I could say, is that what I want to do? I'm looking, what are the dimensions of the rectangle? I could say this. We don't know the length. We don't know the right. But I could say, if I wanted to say that, I could say then that if W is equal to L over, or 135 divided by L, right? Okay. Then I could substitute in for W this, and then I'd have everything in terms of that. And I could say 48 equals 2L plus 2 W's, and W's were 135 over L, right? Then I'm going to multiply everything by L because I don't want it as a denominator. So I get 48L equals 2L squared plus 2 times 135. That's what? 270. And the L drops out of that. And so now I actually can make a quadratic with 2L squared. And then I'm going to minus the 48, so it says 0 over here. So minus 48L plus 270, and that's 0. But now I'm going to factor out a 2. $135. And now I got to factor that. So I got to come up with a factor that's 135, but adds up to a negative 24. That sounds like, am I going to use 2 negatives? Huh. I have to, because I get a positive 135, and that was a negative. So 2 negatives. So I'm thinking here, 5, thinking maybe 15 and something. It'd have to be 15 and 10. That doesn't work. Thinking on this. That was 24. That's 135. What could I get? Well, let's just start. 1 times 35. Negatives. No, 2 doesn't go into it. 3 does go into that. 3 and negative 3 times 3, 4, 39. But that doesn't add up to negative 25. Let's see what a negative 4. Doesn't 4 doesn't go into that. Negative 5 times 21. Oh, wait, this is 24. No wonder I'm having problems. That'll make sense because I didn't take my right B there. Negative 24. So negative 5 times, let's see, that goes twice 27. No, but that's getting closer. Negative 5 times negative 27. Nope. Let's put the 7 go in there. Just trying out my things here. 7, no. Let's try 9. 9 goes into 35 times 1. A negative 9 times 1. And 15. A negative 15. It is 9 and a negative 15. Negative 9, negative 15. See, it just took some time. You just got to try it. And so I have this factors down because A is 1 right here. This is L minus 9 and L minus 15. And then I get 2 possibilities. And that's times 2. And I'm just going to move the equal 0 over here. So the 2 we don't have to worry about, but L minus 9 equals 0. So if that's the case, the length could equal 9. And if the length equals 9, what would be my dimension? The other one, my width would equal 15. And we're going to talk about that in a second. And the other possibility is L minus 15 equals 0. So what if my length equals 15 and my width equals 9? Which one should I choose, or do I have 2 possible sets? Well, in construction and in our mathematics classes, length will always be the longer side. So we would actually choose this number set to be our solution because length is longer than width. And this, in this case, 15 is greater than 9. So we would choose that. I do want to do it with the computer to see what they come up with. The area of a rectangle, they've got that, and the perimeter, right? So they go ahead and they decide to solve. They take this 2p, no, 2l minus 2w. They had it equaling what, 48? They decide to solve for L. And they get 48 minus or plus 2w. Wait, this is plus here. Minus 2w equals 2L. And then they divide by 2, and that's where they get 24 minus w equals L. So now in place of, so they use the area to solve it, but width times length, and this is the new length right here. And then they do this. This will make it probably a much easier problem. Oh no, we got the same thing. We end up with the same thing, don't we? Of course, we would expect that. And they're going to say that we should choose the length to be 9, not the solution, because generally length is greater than width. And in this case, that's not what we have. So we wanted to choose this set of numbers here. Okay. Here a man wants to build a block wall shaped like a rectangle along 3 sides of his property. It's shaped like a rectangle. If 180 feet of fencing is needed, so the perimeter of that part is 180, but we're going to have 2 lengths but 1 width would equal 180. Do you agree? 2 lengths, 1 here and 1 here, but only 1 width. It would equal 180. And it's going to fence off an area that's 4,000 square feet. So right from here, I can see if I solve for W, W would equal 180 minus 2L. I can use that in this formula down here. So I would have L times width, which is now going to be 180 minus 2L equals 4,000. And now I have, I'll come over here, 180 L minus 2L squared equals 4,000. And here's what I want to do. I'm going to move everything to this side. And the reason is I want this L squared term to be positive. So I'm just going to move it that way. So I have 2L squared minus 180L, because I'm going to move it over here. That will change it to negative, plus 4,000, because it didn't move, it stays the same, equals 0. I can factor out a 2. So I get L squared minus 90L plus 200. And then when I do this, 200 here, negative 90 here, and I'm thinking, how about 40, negative 40 times a negative 50? They add up to negative 90, but they multiply to that. So I get L minus 40 times L minus 50. And these are all equal to 0. And the 2, we don't worry about that 2, though. It doesn't have a variable with it. So the length can equal be 40, or the length can be, this is a 50. And if the length is 50, what is the width going to be? So let's go back here. If the length is 50, we're going to find out the width. So 180 minus 2 times 50, that's 100, right? So if the length is 50, the width is 80. Did I do that right? 2 lengths. Yeah, 180. And if the length is 40, hold on a second. Didn't do that right. If the length is 50, yeah, 180 minus 100, that's going to be 80. So the width would equal 80. But if the length is 40, the width would be 100. And in this case, we would just want, it doesn't really ask us length and width, but we kind of did it that way. It was just called them L and 1. And technically, this would be the length and this would be the width. But we would say either one of those could work, because it will work out so that it works. In this case, let's watch and see what they did. I just used my variables a little differently. I could have used A and B, and then we determine which is which afterwards. Let X, and they use X, and that's better than what I used. But here they have it. So we could have 50 and 100. So, well, it could be 50 by 80 or 40 by 100, and that's what we just figured out. Okay, here we come back to our integers. Okay, the sum of the square of two consecutive positive odd integers is 202. Find the integers. So let's go back through that. The sum of the squares, so we're going to square our numbers, of two consecutive positive odd integers. So number one is going to be n. Second number is going to be n plus 2 because these are odd. They're also going to be positive, so that's going to play a difference. So the sum of the squares. So n squared plus n plus 2 squared equals 202. Now, what do I do here, guys? I can't just write n squared plus 4, can I? No, there's a middle part. So it's really n squared plus 4n plus 4 equals 202. And now I'm going to bring this 2n squared, combine those two, plus 4n, and I'm going to subtract 202, and when I do that, I'm going to get minus 198. And now there's a 2 that's common. 99. Oh, I can see that one already. That's going to be x plus 11 and x minus 9. Added together, they make a negative, not 99, just 9. Added together, they make a positive 2. Multiplied, they make a negative 99. We don't need to worry about the 2. There's no variable attached. So either x plus 11 equals 0. So then x would equal a negative 11, or x minus 9 equals 0, or x would equal 9. So let's look at one other clue. Positive. Which one can I throw out? That one. So my number is 9 and 11, and that is the only answer I can have because it did make a constraint saying they had to be positive. All right. Let's look at some further things. Oh, I just need to clear my board is what's going on here. See, they're doing the math the same that we did. They factor it. N can be 9 or n can be a negative 11, but we know a negative 11 doesn't work because our problem said they had to be positive odd integers. And so 9 and 11 are our actual answers. And you could check them, see that they work. 9 squared plus 11 squared, 81 plus 121 equals 202. That is it for us on this. So good luck and enjoy the rest of your day doing these real life quadratics that we're kind of looking at, or applied quadratics. And we'll